and I'm audible. So what we will covering today? Today is our fourth day, and we will be covering certain topics, very basic topic. We will mostly spend the day on notebooks. So before we start, you can open your notebooks slowly, and so we will be starting with basic scalars, how we can use scalars and vectors, basics of linear algebra, and then moving to matrix, different matrix functions. We will be seeing like matrix multiplication, cross dot products, how we can use Python to do that, and a couple of other advanced topics on matrix that we'll be covering, and then a bit of tensor we will be touching at the end, followed by linear programming, solving, optimization kind of thing. So that's what we will be doing today. And uh, and it, it's I, I hope all of you are aware with basic matrix things that we had in class 12th 11 12 thing, or if not, I can on the go I can do some of the analysis on the Jamboard. So to start with, so this is the linear algebra which involves a lot of mathematical object. The first thing is a scalar. So what is a scalar? Scalar is a simple single number that we all know from the algebra. So anything like, for instance, number 12 or any numbers, that is a scalar, or just a dot, single value thing. So how we can use that in Python? So first class we have seen that we had basically assignment of data types. So we had you can just declare a scalar as an integer. So s3, s3 or something should help you. I just right. So this is your integer, but then we can assign a variable like that, but we have to use, when it goes up to a vector level or to matrix or another level, tensor, then it's difficult to maintain these things. So it's better to have a proper structured way to define these things. So a structured way for that is NumPy. So we are going to use NumPy that we introduced in very first class. It is very useful for Python, numerical Python. So we have NP, and so you can define an array as numpy array and then a value just next to it. So numpy array n3. So I'll keep pasting these things on the comments so that you can follow up. So this is basics of a scalar, how you define a scalar and how you define scalar via a numpy array. You can do that. So followed by we have a vector. So what is a vector? Anyone? How you define a vector? So vector has basically two things to define. For defining vector, it has to be had a particular magnitude. What is the magnitude of a vector? Not only a magnitude, it has to have a direction of the magnitude, right? So here we will basically think vector as a array of numbers, so that is has both magnitude as a direction, right? So we will come to that, how we can calculate the direction. But to start with, how what you can define is the vector as a array of numbers, right? So np array you can use, and then you can print the simple, just print the array. That's your another level, that is vector, when you add a lot of uh, numbers. So this is your vector, how you define the vector. So for this vector, let's calculate its magnitude. So for that, you can use one thing called uh, norm. So it will give you the norm, and that is basically your fast normalization it's giving. So it's adding basically sum of all these things and square of all these things, adding and subtracting, right? So we have v here. So you can get the magnitude. Yeah. So this is the numpy formatted. So can you just try to get the magnitude without using numpy? How will you do that? Given a vector, can you write a small function or code snippets that will give you, given a vector as a numpy array or as a list, you can use that and get a magnitude of this. So what essentially is doing squaring of everything, adding and getting a root of it. Just simple, like how you square it off. You can use double star for that. Anyone, if you're doing, just you can paste it on the chat. So how you basically do that? Let me go back to. Are you seeing my screen, right? This Jamboard screen. So if I have a vector like, so if your vector is some 1, 2, 3, what your magnitude will be? 1 square plus 2 square plus 3 square. So this is simple. 1 plus 4 plus 9. Square root of 14. Okay. Similarly, what is given to your so this is, we can change this. So what we had here is 3561. So you have 3 minus 561. So it has to be 9, 25, 36, 100. So just sum it up. 1, 7, 12, 9, 1, 71. It's coming. So that's why it's coming around uh, 8.42, right? How you does that without using numpy? 8 point something. This is coming 8.1 or something. So more simplistic way you can import math. So you can. So, so see, you can also get the same numbers. So what we are doing here, we are square rooting the sum of the individual numbers. Or if I have to break it down, um, okay, let's break it down a bit maybe. So what is your list for all those things? So if I do this, what is your magnitude coming? Uh, Let me give a list in some sense. Okay, we this. So now this is the square of that thing that we have, and then you can get it as a set also. No problem. So your set is generated. Now you can get the sum of it. Sum is 71 that we got, and then you are using math to get, or you can use either way. Math you can use, say, double star point 0.5. If you don't want to use even math, this is also fine. See, same answer. So these are the different ways that you can get the value of this magnitude. You can use simply Python program in linear algebra norm, or if you want to use math, you can use math. If you don't want to use any of these things, that is also fine. You use the formula we have seen yesterday. Multiple things that you can use by default formula, or you can actually implement the formulas that you have with you to get the magnitudes. Right, so I'll post all the codes also. Anyone having any issue with getting this as of now, or trying this? Can anyone respond? Okay, then let's move forward and see how the things going on. So the next thing we will be getting is basically two non-zero vectors you have. What is the dot product? And so what is the dot product? Okay, and cosine angle is basically their values between. So let's come back to the board again. So if you have two vectors, say a is a vector and b is another vector, so your dot product is a b cos theta, right? So if I want, if two vectors are like this, and we know this is a, this is b,
అదే అదే ఒకసారి మన కోసం వస్తేమో
and your angle is theta, so this is your
నేను చెప్తున్నాను
formula.
ఒళ్ళే ఊర్లో వాళ్ళు
So
రాను
cos theta will be ab
అందరు పోయాము దానికి అరే వస్తే ఏం పోతుంది ఏడుండి
right.
ఏం చేస్తాడు
So
భూమి నుండి ఏం పీకుతాడు వస్తారా
this is ab.
పరిసరాలు
Now a b you have dot, and then this also you can for use this magnitude formula. These are the magnitude, right? Magnitude of a, magnitude of b. So can you just do the same for these two? So how we does that? We define two NP and then finding their cosine angle, right? So we have a dot product of that. So dot product we can use just dot b, and then so we have a NP that we used here, linear algebra normal norm. So that is for magnitude of a multiplied with magnitude of b, right? And then converting it to, so degree. It's 40 degree basically. So first we are getting cosine angle and then converting into degree. You can check also the values for NP. If I print this, you can see the value of a magnitude, b magnitude also you can print and see, and then you can see the angle between these two. So this is useful when you want to get the angle between any two vectors you have, using this formula, right? The formula we have seen here. This is simple thing that we performed here using Python. So given another set of values, will you be able to get that? If I give you two vectors like a equals to some 2 minus 3 4 7, and b equals to say 5 3 2 minus 1, will you be able to calculate the theta between them, or angle? What is the angle between them? Can you calculate this? I'll type in the chat also. So your a looks like 2 minus 3 4 7, and b is 5 3 2 minus 1. Can anyone tell me the just degree? The same code you can use. You can just change the a b there and get the results. I'm not asking you to write something. Anyone can tell me the angle? If you have any doubt by this time, if you are lagging in any step, just let me know. I will stop and re-explain that part. Can anyone tell me the angle or type in the chat? So if you do this, this will come 80, 87, 88 degree between them. So you can just change these values here and do that. Now we can do couple of other things also. Let's move on. So if you have an array, you can do scalar things as well. So it's not always you have to do that vector stuff, right? So you can do scalar things as in just multiply it by 3. So it will what it will give you. It's a scalar change. So it will multiply everything with 3. So now you have 9 minus 15, 18, 3. So that is scalar multiplication, right? And if you do v plus 3, it will add plus 3 to everything. Okay, so 3 minus 2, 9, and then 4. And you can also do scalar addition. So if you have, just comment these things and uncomment these things. So if you have two things, two array, and if you want them scalarly add, right? So just add them. So you can see a new array is the addition of 1, 4, 2, 5, 3, 6, and 0, 7. So 7. Similarly, a minus b also you can do. So minus 3, minus 3, minus 3, minus 7. So these are scalar function that we performed on vectors. Multiply everything with similar element. If you want to scale anything up, you want to scale anything down, change the scale of some variables that you have, you can do that thing. Or you want to anything shift from one side to another side of any values, you can do that thing. So basically what is the help of this thing? So you if you have a vector like this a, and you want this vector to go like this. Okay, I'll try to draw it properly. Okay, so this kind of shifting if you want, or then that is that thing. If you want to change magnitude, multiply. If you want to, so this is scalar multiplication. If you want this to move in this fashion, so then say a equals to 3, so you adding 3 to all the elements, so adding 3 to all the elements that you have here, and you will get the shift. So this kind of shifting of vectors can be done using scalars function onto the vectors, right? I'll also copy paste these things in the chat. Okay, so before moving into matrix, I will just recall you what we have seen with scalars and vectors. So scalars are like as an integer. So you have scalars. You can introduce scalar as a numpy array for multiple functions that comes with numpy. You can use them. You can declare that as a scalar. So simple scalar. Coming to vector, you can actually vector is a has a direction and a magnitude. So you can identify. So direction is identified by the angle also, and then you have that magnitude you can calculate using your numpy linear algebra module. Norm has there, and then you have magnitude can be calculated using square root of math, or just simply using this formula, the formula we have seen, right? And then if you want to get the angle between two uh, arrays or two non-zero vectors, essentially they have to be non-zero. So you have dot product is a dot b, and then you can divide that with magnitude of a and b multiplied. And then this is you are converting that to angle, and this is our arc cos is basically doing reverse of cos. So this is a cosine angle, so this will do anti-cosine kind of thing. So so this is that thing. And then you can do move you can basically move a vector by repositioning it, and using different scalar functions you can use. So just give you a couple of minutes, you try the things I gave you before we just jump into the matrices. Please let me know on the chat if you are not getting anything, or if even getting something, you can just let me know. Or if you're stuck somewhere. So the important part is this one. Okay, so let's move forward to the matrix. So what is a matrix? Like, very simple uh, definition is a set of numbers particularly organized into rows and columns, right? So something like a equal to, you have say 1 2 3 4 or something. But this is the matrix we know. How we form it in the Python? So Python, we will be using np array, and then two lists for each of the rows, right? So your matrix comes like this. For every row, you have a list. So this is a list structure, and or you can say two vectors. So it's a different kind of vector. So you have two vectors assigned over uh, rows. So we define as a rows thing. You can also, transpose that to get a transpose of this matrix. But anyways, this is the way to, show the define a matrix there. And then you have these things. So what we are doing here, basically, we NP arrange will give you uh, 1 to 6 or 0 to 5, basically. Sorry, it starts from 0. And then if you are reshaping it, you are basically arranging it in the matrix format. So reshape in the proper matrix format 2 3. You can ask it to 3 2 also, to basically, uh, redefine it as a 0 1 2 3 4 5. You can, so this is a way to create a simple matrix. So you can do 2 5 or something like this. So this is how you define matrix, and then you can get basically matrix shape. So shape is 2 cross 5. So we are reshaping it. Now here for M, what will be your reshape? So if I do M dot shape, so this is 2 cross 3. So your matrix shape you can go. So number of rows, number of columns, you can get using shape. So similar shape is, proceeded and used for pandas. If you have any data frame, you can use. You remember the second class we discussed pandas dot shape. That will also give you number of rows versus number of columns. And then if you want any specific value, just indexing you can give, right? So indexing is 0 2 is 2, right? 0, so 0 is the zeroth row, and then 2 is the 0 1 2 column. You can get, say, 1 3. So what will be the output of 1 3? Can anyone put it on the chat? Any idea what will be the 1 3? Any idea what will be 1 3? 1 is your 0 1 number row, is this one. 3 is 0 1 2 3. So 8 has to be the answer. So you are getting 8. Right. And then you can also generate identity matrix. So NP identity will generate you an identity matrix of size 3, or whatever size you want. You can, if you want identity size of 4, it will generate. So identity matrix is your, identity matrix is your I. That is, diagonal elements has to be 1. So this is a 3 cross 3 matrix. So these are all 0, and this is the diagonal matrix. And then we have, just addition of matrix. So addition, if we have A B C D plus you want E F G H, so this will be A plus E, B plus F, C plus G, D plus H. And then negative is also same. Let's come to multiplication. A B C D E F G H. This is a tricky. So we have first this, then this format. So so this will be A E plus B G. So first this A E B G plus second this will be A, again this one A F plus B H, followed by C C E plus D G, followed by D D F plus D C F, sorry, followed by C F, this way C F C F and D H. Right. So this is basic matrix that you all are aware of, but how we do this using your Python. So Python, we defined a matrix, and then you can find also determinant. Right. So this is for determinant. You can use determinant to get the determinant of the matrix, and then if you want just transports, you just have to do C dot T. That's it. So this will give you transpose. Okay. So 1 2 3 4. So 1 2 3 4 comes like this. 8420. This comes 8420, and 4032 comes 4032. I assume you can see, but I will still increase the size. It's better. If anything is not visible, or if you're not able to hear me, just let me know. And then there is inverse of matrix. So I'll just paste this two thing here. So determinant, to get determinant is this thing you can use, and then transpose is something dot t. That's it. Right, and then inverse is basically you can do NP, linear algebra inverse. So a lot of linear algebra thing is comes with NumPy linear algebra package. So first we will be seeing. So let's print E. E is this. Then inverse. We printed inverse, and then according to your it has to be a inverse. So dot, this is the dot product. Dot product is give, is you have to give I is your identity matrix. So either way your dot product should give you identity matrix. So let's see that. So this is also identity matrix. So why you are seeing this numbers here? So this is 1 e to the power 0, this is 1 e to the power 0 is 1 1, and essentially this two has to be 0, but you are not seeing 0. Some small values you are seeing, very small values, that is supposed to be zeros. Why that are coming? Anyone? Just we had that discussion in first class. So is this correct or not? Is the inverse is correct or not? Because it's not 0, it has some small value, essentially 0 only. Why that value is coming? You can unmute and tell also. Anyone? So just to give again brief of these things, I have shown you the multiplication, and so identity matrix also you have seen. So determinant, you most of you know. So I'll just briefly tell. It will give you so determinant will come before that. We also have a inverse. No inverse we have seen inverse of matrix also. So a inverse is basically you if you have a something like, let's define a is something like a b c d. What will be determinant of a? Determinant is cross, right? So you have to ad minus bc. That is your determinant of a. And a inverse is what? A inverse is determinant A, and then so it has to be changed, no? D minus B, and cross, this has to be cross, and then you have minus C A, and then this has to go like 1 by AD minus BC, D minus B minus C. So this is inverse. So these things we just saw here. So we have an inverse of that matrix, and we have validated that these things, and this is happening due to floating point error, right, that we discussed in the first class. Like it can store up to certain values, and if it is exceeding that value, it is basically it will store it like that. So essentially both are your identity matrix. So this is one diagonal one, this is 0, and this is 0. Similar way here. Matrix multiplication can be done similar way, considering these are numpy array. You can use np dot both. So once you have two matrix defined, so so first thing that we are seeing here is np dot m cross n. So this will give you matrix multiplication. These are both at the same matrix. So essentially that thing, you can use this at the rate, just as a fancy stuff. So that will also give you this thing. You can also use another function called matmul, that is matrix multiplication. That will also give you the same thing. So these are the three different ways to do matrix multiplication, right? So I'll just paste this also in the chat. These are for matrix multiplication. This is for inversion, and this is for your the transpose we have seen. So another stuff is matrix power. So what's the matrix power? If you have a matrix, say A, B, C, D. So if I want, so this is called M. So M square is not equals to A square, B square, C square, D square. So you have to do M cross M. That is A, B, C, D cross A, B, C, D. Then you have to find, right, what all will be the answer. You can use matrix multiplication. So basically to do that, how you can do it is here. uh, you can use numpy matrix power, and then give it a power. Say let's get the matrix 1 2 2 4 1 2 2 3, and power is basically 5 8 8 13, right? You can also do multiply this. You can get this as a m3 also. And if you decide, you can do multiple time of this, or just simply, power you can give and get it. So this is matrix power. So these are some basic topics of matrix. I'll give you another couple of minutes so that you can try these things, and then we will be moved with the advanced topics of the matrix. So if it is too much, you can like get a quick break, maybe 3 4 minutes, and then I will be here. If you have any questions, you can ask me, and then we will be starting with advanced topics of matrix like rank, and then uh, SVD. We have eigenvalue, eigenvector. Those stuff we will be doing with matrix after this. So just make sure the basics of this matrix are clear in your mind. You can take a short, quick break, and then we will be starting another couple of like 3 4 minutes or 5 minutes maybe. If you have any question, you can just let me know. I can go over this course once also if you want. Okay, so let's start again. So we will be starting with rank of the matrix. Okay, so what is the rank of the matrix? So rank in linear algebra matrix is the dimension of vector space generated by its column. It's corresponding to the maximum number of linearly independent column. So what is that? So imagine you have a matrix, say 1, 2, 3, 2, 4, 6, 9, 9, 7 or something. So what is this? This is a 3 cross 3 matrix, right? And is what is rank? Rank is number of linearly independent variables. So what is linearly independent? So if you think columns as a vector, this is vector 1, this is vector 2, this is vector 3, right? Then you have to see whether they are linearly connected or not. Linearly connected means v1 is some function of v2, linear function of v2, right? What is linear function of v2? Can we fit something like this? Seeing your v1 is 1 2 3, how you can make it as a v2, that is 2 4 6? Can we linearly connect it? The answer is yes. If you put a half here, or mathematically say zero point 0.5 of your vector 2, then only you can get this thing. So this is a linear fragment or a scalar value. So if you have this kind of linear equations, that says these two columns are connected, right? That means you can reduce this matrix. So basically if you multiply with this, so and then you can do that, right? And then all the columns you can turn zero. So 1 2 3, if you multiply, uh, you know column 1 multiplied by column 2 minus column 2, say column 1 equals to that. So column 1 everything will be 0 0 0, column 2 will be 2 4 6. I'll just redo this. So column 1 will be then 0 0 0, column 2 will be 2 4 6 9 9 7 or something. So we can reduce this. So this will be now, so the rank of this matrix cannot be 3, this is 2, because we cannot reduce this now, as of now what I can see. So linearly independent columns are your rank. So here you have these two things, are these linearly independent or not? So first we will be seeing, we have two matrices. So let's see. So as of now, this matrix M, I'll just print it. So you can see 1 6 6 8 9 3. Nothing as such. I can see any differences. So let's see what is its rank. Rank is 3, right? Now if you have, I give you another matrix which is 1 2 3 2 4 6, the example I showed you, and then some non-related thing. What will be the rank of this? Yes, this is correct that you said. So what will be the rank of this now? This will be 2, right? Because these two are linearly dependent, not independent. So let's come to the next topic, that is eigenvalue and eigenvector. So eigenvector is a vector that, so if you have this kind of situation where you can represent a matrix, a v as a lambda v, where lambda is some scalar, then that is your eigen vector, and the value you get out of is the scalar. The eigen value of a is a scalar. Then it's a non-solution, and then you can get the eigenvector, right? V is the eigenvector here. So this is the eigenvalue. So this is the eigenvector, and this is the eigen value, I guess. Okay, let's see that. Let's comment these things, and so first find the rank of this matrix. We have a matrix. Before that, I'll just paste this here. So we have this matrix, and we get the rank of it is 3. So actually you can see we have, I will just print A also. So you can see the shape is 4 cross 4, but rank is 3. Okay, so these two columns are associated, right? 2 3 4 6 4 3, or I have to see which two are connected here. Okay, these two. If you see these two, 2 4 3 6 5 10 2 4, right? So this is, that's why the rank is 3. So what is the eigenvalue and eigenvector? You can get that also using the function called EIG. Just paste this as well. So these are the eigenvalue, eigenvector we had. Uh, let's just understand this with basic something. How you get that with a simple example that may look, complicated. Let's try with some simple examples. So let's consider a example, say something 1 4 minus 4 7 minus. Okay, so what it is given, like, if I do a minus lambda I, that will come. So 1 minus lambda, your 4, minus 4 minus 7 minus lambda, right? So uh, lambda is for only just. So lambda I will looks like minus lambda 0 0 minus lambda, right? So this is lambda I. and a minus lambda I will looks like this. What will be the transpose of sorry, determinant of this will looks like your 1 minus lambda. So this will be 1 minus lambda, 4 minus 4 minus 7 plus lambda, and then multiply this 2 minus this 2. So 1 minus lambda minus 7 plus lambda minus minus 4 cross 4, right? So this will come as plus 16. This is your 7 minus 7 lambda plus lambda minus lambda square. So this is lambda square minus 6 lambda, so plus 6 lambda, and this is plus minus 7, so plus 9. So lambda plus 3 whole square. And if you put that as a 0, so lambda plus lambda equals to plus minus 3, right? No, lambda is both square, so lambda will be only minus 3. So lambda is minus 3, minus 3, minus 3. So these are your eigen value. So let's go back to the thing, and if you see, you can calculate the eigenvalue of this matrix also, and that should come as a this vector. So our so eigenvalue is minus 3, minus 3. Here you can have, that's why you have 4, so you have 4 4 values here, right? And how you get the eigenvector out of it is like using that equation also you can get actually. So you have ax equals to lambda x, right? And then you can have lambda value is minus 3x. So you know that, and now you know a minus lambda I of x equals to 0. Now if you solve that, you will get the equation. So just continue with this. So I will just rewrite this lambda x. So lambda is equals to, now it's minus 3, so minus 3x, and a minus lambda I of x equals to is 0. So a is your 1, 4 minus 4 minus 7, and then this is minus 3, so it will be plus 3i, right? So plus 3i is 3003, and then your x is some say xy small, that is equals to 0 0. Can you solve it to get x or y? So let's add these things. So 3 1 4 4, you get minus 4, and then is again minus 4, right? So that is 0 0, and then sorry, here you will be having xy, and xy equals to 0 0. So either way, it's basically your 4x plus 4y equals to 0. Or essentially you can write minus 4x minus 4y equals to 0. Both are same. Or essentially your x plus y equals to 0. Right. So this is one simple example that I'm showing you. And now if you want to say assume something x equals to k or something, so your k plus y equals to 0. So y equals to some constant minus k. So once you write x equals to xy, and you can now write that is equals to k. So k is x, so that's 1 minus 5, right? So this is your eigen vector. So that's how you got these two things, and for this complicated equation you can generate simple using Python. So I pasted this, you can try this. Now if you know the eigenvalue and eigenvector, can you calculate construct the matrix? The answer is yes. So there is this formula which gives you like the opportunity to construct the matrix given if you know the eigenvalue and eigenvector. So P is the matrix whose column are the eigenvector of A, and this lambda is a diagonal matrix whose diagonal entries are the eigenvalue of A, right? So given that, so how we are constructing, we have this eigenvalue and eigenvector. Let's see. So we have eigenvalue, we have an eigenvalue. Let's see what is that. And we have another eigenvector. Eigenvector. Now, given these two things, can we construct get this matrix or not? Okay, so we have only these two. So how we have to do that? So what you are doing basically is a dot of p lambda and then p inverse, right? So p, so this is dot of uh, so this is inverse of p inverse, and you are doing dot with your diagonal of eigenvalue matrix. So this is diagonal 2. So eigenvalue will be replaced in the 2. So let's see that how it looks like, and one by one we will do that. Okay. Mm. So what is this? This has all the zeros, but your eigenvectors, that is according to the diagonal 1, 2, 3, 4. So that is your this lambda, right? So if you are doing dot of p p delta and then p lambda and then p inverse, so that will give you this matrix A3. Sorry, we were here. Yes. So this should give you a matrix, right? So this is the matrix we had, and then we are doing eigenvalue diagonal that we had here also, eigenvalue diagonal, and then dot product of with inverse of the vector, and then eigenvector dot. So that this is the one eigenvector dotting with lambda, and again dotting with inverse of eigenvector, right? So this will give you this is the actual matrix we have, and then similarly we got the same thing: 2 4 4 2 3 6 3 3 5 doesn't look like the same 1 6 2 4 1 6, but this has to be 0. Okay, this is 0 actually. So this is due to floating point error, so that's e to the power minus 15. So essentially this is 0 and this is 1, so both are the same thing, right? So essentially, if you have a particular eigenvalue and eigenvector, you can basically get the matrix out of it. You don't need to. So that's very fundamental of a matrix. So this shows that you can also calculate, power of matrix using the eigenvalue and eigenvector. So both are coming similar. So this is multiple ways to calculate similar thing. You can use uh, your own formula, or you can use their linprog basic or linear algebra basic formula from the numpy. So if you have any doubt with this rank or eigenvalue, eigenvector, or construction of matrix from eigenvector, we can just try that again on notepad and check how we can do that. So please feel free to stop me if I'm going too fast, or if you have any other comments, just you can type it on chat. Also, you can use this, system of equation. You can solve a system of equations using matrix. So if you have, so this is say x 0, and or you can consider this an x and y, and then linear algebra solve will help you to solve it. So you can get a value of x and y. So this is essentially 1 plus, just try to write it, x plus 2y equals to 1. So essentially it's x plus 2y equals to 1, and you have 3x plus 5y equals to 2. 3x plus 5y equal to 2. So if you want to solve it using matrix, so you have to construct it, and you can just a should be your uh, x and y values. Here we used x0 and x1. You can use xy, and then b is the solution, and then like answer, and you can solve to get what is the value of x. So this is x and y. So x is -1, y is 1. This is very useful when you want to solve a lot of linear equations. Okay, let's move to the next thing. And the very fascinating thing that is called single value decomposition. Single value decomposition of a matrix is we have to divide that matrix in such a way that it comes up from three matrix. Okay, so three matrix has different use of it. So your three matrix should be one that is the orthonormal eigenvector of AAT. So A is the matrix that you want to split, and split into a way that it gives you three matrix. One has to be A transpose, eigenvector orthonormal matrix of eigenvector A transpose. Then V is the second thing, that we have a transpose of a n cross n matrix that containing orthonormal eigenvector of ATA. And then is a n cross n diagonal matrix with singular value square root of the eigenvector. So don't need to worry about this. Let's see how it comes out, or what are the three matrices you are getting. Okay, I'll just paste this for you to try. So so you can see this has to be a identity matrix, right? So if you multiply u dot with u and t, so you are getting an identical matrix here. So these are the, so don't get confused with this term. These are basically zeros. So 1 0 0 0 1 0, and then 0 0 1. So these are coming due to floating point error. And similarly, again, if you do v dotting with again vt, then also you are getting another identity matrix. So this is another form where you can split the matrix into different matrix, and see, these are the characteristics of this matrix, and the decomposition that you can have. I just paste also this, you can try. Okay, let's come to the next thing, that is null space and nullity. So what is a null space? Null space is a space or a set of vectors, you can call it vectors. For all such vectors, your ax will be 0, right? So it's a set of values, all the values that satisfied ax equals to 0. So all the x's will be here, right? So that is your null space, right? So null space is a very important thing, that also we can complicated mathematically we can write null of a is for all x belongs to R real, your ax is equals to 0. So this is mathematically we can show the thing, that is your null space, right? And also, so what is nullity? Nullity is the matrix for which these x are 0. So let's see that. So we are, so for this you have to import sympy from the matrix, uh, and let's generate a matrix first. Let's get a printed. So this is a better format, so you can see, so you can use this matrix to see the actually this format. And then null space of a should be, okay, I have to print null space also. So this is the matrix of null space, right? This is in matrix format, that's where it's coming, null space. And then yeah, so you can use also this matrix symbolic Python, and then a matrix to show the better, show it in a better fashion. And then check this also, you can see. So when you get the null space, so anything that you're multiplying with ax has to be 0. So this is coming as 0. Just yes. That you can use also matrix to see it in a matrix format. Okay. So this is, and so nullity is, and rank should be the total number of attributes. So rank is whatever is giving you non-zero values, that is basically linearly independent rows or columns, linearly independent variables in your data. And this nullity will give you the other half, that is dependent, so that is giving you the zero values. So combining both will give you essentially the number of rows or number columns, or usually similar. And then that goes for your total number of variables or attributes. So nullity also you can count in this fashion. So what is the nullity? Is the number of possibilities for that. So if you have rank is 2 and total shape is 3, so if you do minus, you will get the nullity is 1. I'll paste this as well. So this is very important. Just remember that nullity of a matrix, if added with the rank, will give you the total number of attributes or total number of columns or variables in the matrix. So let's pick up this matrix. Can you calculate the null space nullity for this? I've given you the another matrix from the earlier thing. Can you just get the nullity rank? I'll just list it down all the things. So you have to get null space, nullity, and rank. This the thing can you do for this as an exercise? Placed it in the chat. Still, I will try and find the null space, nullity, and rank of the matrix is given here. Anyone, any idea? Some you got some rank, at least rank you get nullity, or if you get rank, nullity is just easy. Okay, let's start with this part. Let's see the matrix. So this is the matrix, right? Let's get the null space. A dot null space. A dot null space will give you a null space, and then let print the null space. So this is your null space, right? If I write matrix null space, this should. So this is your null space. Simple. Then let's get a dot shape. Okay. Shape is shape we can write just using 4 cross 4, right? And then if you get the number of rows and number of columns, so column is 4. And then a dot rank you can get also. Just check the rank, or just simply do it here. Sorry. So rank is 3. So nullity is 1. Simple. Okay. Total is 4. Rank is 3. Nullity is 1. So that's why you have only one value in the null space. If you could have 4, 6, 10, 4, let's change this and try this again. Mm, let's say this could be 4, 6, 2, 12. So this is the twice of this. So let's see one by one all those things how it changes, right? Now I reduce the rank to 2, right? So let's see. So rank is now 2 because these two I also linearly connected them. So your nullity is now 2. Rank is 2, total is 2, so nullity is 2. So what is our null space? See, you got two sets of values, right? Earlier you have one set of value. So now you have a lot of more values to establish that. So this is the set for which all the, so this is basically a set for which all the values are, so this matrix A cross S could be 0. So now you got more values, more possibilities because you have lesser rank. So another quick topic that we will quickly cover today is called tensor. Tensor is nothing but set of matrix. So we had scalar, we had vector, then linear thing vector, then we comes to three dimension where you have multiple vectors combined into a matrix, and then multiple matrix if you combine, that is your tensor. So you, how you create a tensor? So this is two matrix. So this is one matrix, this is another matrix, and this is under a matrix called, that's called tensor. And so it has shape called x, y, z, z. So 2, 2, 3 is the, so two of matrix each of 2 cross 3. That is your tensor, right? So I'll just quickly go through it. So this is multiple. You can see this is one bracket, this blue to blue, and then this is another. So this is your tensor, and then tensor shape also you can get. Similarly, tensor you can get operations like this. These are the two tensors that we have. You can just do simply c plus c, simply sum, division, subtraction. So c plus c is giving you another tensor. Okay, so three matrices, it's addition, simple addition. And then subtraction you can do simple subtraction because both are same, that's why this is giving. So if you have noticed, this and these are the same, so that's why these are the same thing. So 0. And then multiplication, interesting. It's a bit it's just multiplication of each of it. It's not tensor multiplication, it's scalar multiplication of tensors. And then divisions is 1. So these are scalar operations that we have performed on the tensor. But now we can also do dot product. To do the dot product, you have tensor dot, like the dot we had for numpy. So this will give you tensor dot product. So I'll just paste that to you here. So these are tensor and tensor dot product. So it's a group of matrices that you have with you. So just spend 1 or 2 minutes on the tensors. You can try that thing, and then the last topic for the day is optimization. So we'll quickly see the how we can do lin prog or linear optimization of the thing. You can hover over these things to actually see what is there, what are their documentation. So it will help you to understand also. So you can make tensor also. I'll just paste this. Both are the same tensors. Okay, so let's move to the last part of the day, that is optimization. So if you remember, we all keep doing the example of in class 12th we had that optimization. You have the this many kgs of logs, wooden logs, and if one chair takes 5 kg and then one table takes 3 kg, how many maximum, how and each of these costs some 3000 4000 rupees, and how many chairs and tables you made out of say 50 kgs of your log to get highest profit. So that is sort of one optimization problem we had, and similar kind of problem we will be having here. So we have a function that is x and y, consider that as a cost, and then you can make number of so each of them has a constant. So x cannot be more than x has to be more than 4, and x2 cannot be more than 6, and there are some cannot be more than 8. So this is basically we have a so this is basically mathematical representation, and given a matrix C, C transpose is X to be minimized or maximized, depends on your requirement, and there will be certain constraints. So you can do like this. So here you have objective functions, and then you have left hand side inequality, you have right hand side inequality, and you can ask linproc, that is linear programming, to actually solve and optimize these things, right? And then this will give you the function value. Function value is the value that we are trying to address here. So this is one thing that is, you don't need to probably much worry about, but this is another thing you can do using this matrix things to solve the uh, different functions and optimize the functions. So that's it for today's class. And so what I will just recap you what we have discussed today. So we discussed starting with scalar, we discussed vector multiplication, magnitude of a vector, angle between two vectors, and then we had matrix. In matrices, what we have seen in I just put it in the slideshow. So in matrices, what we have seen how to multiply, add two things, add two matrix up to all those scalar stuff, and then matrix product, how to product matrix square, for then going to rank of a matrix, single value decomposition, then went to nullity and null space of matrix. Then we have seen how we can use matrix for simple solution of multiple linear equations, and then moving to tensor basic, what is a tensor, sum of sum and other scalar things of tensor dot product. We have seen just that's the optimization of the using these matrices. So I'll just put this in the GitHub and share the link of this page with you right away. And meanwhile you can give the feedback also. uh, so you should be able to get all the codes there that I pasted here today. Can anyone just check and let me know? I hope that is working. Okay, I will be here. If you have any doubt, feel free to ask me. And please give your feedbacks so that I can, improve upon the things. So we will be doing regression on the Monday. You can give feedback here as well. Uh, Okay, if you don't have question, you can start leaving. I will be here for another minute maybe, and enjoy your weekends. Okay, then thank you all. See you again on Monday. Have a good day ahead. Yeah. See you. Bye.